Good day, my name's Nick and I'm here to help my students who are studying a PEO Level 1 in Engineering. We're looking at Unit 3 and Unit 23. Unit 3, Communicating Technical Information, and Unit 23, Assembling Electronic Components. I'm being asked all the time about what is a datasheet. Well, here is a datasheet for communicating technical information. This is about a 555 timer. There's a picture of the timer. In order to be able to handle it more easily, I've mounted it into a breadboard so we can see a little bit more detail. What does this datasheet provide for us? Well, it gives us a little bit of information with regards to how the chip is going to operate, the conditions it needs to work in, and what pin we connect to which part of the circuit. So from the picture of the timer, we can see that there are two CAN configurations. The N configuration is what we're going to look at. Then we can purchase varying qualities of integrated circuit. The basic one will run from 0 to 70 degrees centigrade. The most expensive option from minus 555 degrees centigrade to 125 degrees. That's an awful lot of temperature range, and we're going to have to pay a little bit more for it. Other important information: the maximum current the integrated circuit can conduct. If we exceed that current flow, the integrated circuit is going to cook, and that's the end of our activities. So it's important to understand the limitations and applications of this circuit, and they're provided for us on this datasheet. I'll now look at the integrated circuit. There's a cutaway in the top of the integrated circuit. That cutaway, or the notch, identifies pin 1 and pin 8. So there we have it, pin 1 and pin 8 next to the notch. That, hopefully, if you observe that notch, will stop you mounting the integrated circuit upside down into your circuit being constructed. Pin 1 is our ground conductor pin. Pin 8 is VCC. Ground is 0 volts. VCC is our supply voltage. If we get them the wrong way around, the chip will conduct too much electricity, over 200 milliamps, and we'll cook it. The other connections are there identified so that we know which component to connect to which pin to make our circuit operate. The operation we're going to look at is a flashing LED circuit. That will come in my next video. Some more information which is appropriate is to look at an engineering drawing. And this is an engineering drawing. It's drawn in orthographic projection. This is in first angle projection. What does that mean to you guys? Well, it means that we've got 3 views of the integrated circuit. We've got a front view, we've got a side view, and we've got a plan view. And those views present to us the physical dimensions of the integrated circuit, so we know when we buy a breadboard, the integrated circuit will fit in the breadboard, and the pins and the pin centers will match. So if we look at the pin centers on our engineering drawing, we can see dimension E. Dimension E is 2.54 millimeters. That's 2.5 millimeters, and that's the distance of the hole centers between my pins on my breadboard. So I can use this technical information to make sure that the integrated circuit is going to fit into the breadboard, and we're going to successfully be able to build our circuit, which will follow in my next video. So I hope that helps you understand why we have a datasheet, the sort of information that the datasheet can set out when we're looking at electronic components, and a little bit about the drawing work you've done in first angle projection, which is another part of communicating technical information which you need to be aware of to answer the questions. If you found this helpful, please let me know. Otherwise, I hope to see you for my next video, which will be the operation of the 555 timer. Thank you.